So guys, this graph, or this video, is going to talk about the cosine graph and how to graph a vertical stretch, a vertical compression, and a reflection. So I have three problems here to do, and it's the first one deals with the vertical stretch. Okay, so of the cosine function. So I'm going to go ahead and graph the cosine function just so you can see it. So I know my maximums for a cosine function are at 0 and 2 pi, which is 6.28, and that the minimum is at pi. And I have zeros at pi over 2 and 3 pi over 2. Okay, so this is my parent function. And notice for this parent function, I have a period of 2 pi. Okay, so for the parent function, here's a period of 2 pi. And the cosine function, again, is graphing the x values when you do one circle, one revolution, one cycle around the unit circle. When I graph that, which has a period of 2 pi, I'm going to get the cosine function. So this is the graph of all of the x values on that unit circle as you do one revolution counterclockwise around it. So a vertical stretch, let me grab a different color here. This is a vertical stretch. The reason we know it is a vertical stretch is because that a value is greater than 1. So if a is 4, that is my amplitude. So my amplitude for the parent function is 1. So maybe I need to write that down. Let me do that in orange. So parent function amplitude, let's see, a is 1, right? And if I'm doing the amplitude for this vertical stretch, the amplitude is the absolute value of a. So absolute value of 4, well, that is 4. So that means my wave is going to have maximums instead of at 1, now at 4, I'll mark it right there, and at negative 4. Okay. All right, so if I have maximums at 4 and negative 4, then that means that I will have a maximum here multiplying the y values by 4. So maximum at 4, a minimum at negative 4, and notice the y values at 0, well, they're still 0. So this is a picture of my vertical stretch of 4. That means my amplitude instead of 1 is now multiplied by 4. So the y values are all multiplied by 4. The period for this, notice, is 2 pi. Okay? That is a vertical stretch. A vertical compression. Well, let me go ahead and draw the parent function. I do want to point out one thing here. For the parent function, if my y value is at 1, and if it stretches, notice it's pulling the y values away from the x-axis. Okay? So on a stretch, you're pulling the y values away from the x-axis. All right, let's move on to the next example. I'm going to go ahead and draw the parent function just so you can kind of see what happens when we do a vertical compression. So here is my parent function. Again, with my parent function, the amplitude is the absolute value of a. So let's see, that would be 1. Amplitude is 1. Okay, the amplitude is that distance from the maximum to the midline, or also if you want to say the minimum to the midline. So if I'm dealing with a compression of a 1/4, so vertical compression of a 1/4. Well, let's see, that means my amplitude here is absolute value of a, so absolute value of 1/4 is 1/4. If I take my y values and multiply them by a fourth, that will give me my new parent or my new function. So if I take the parent function here, the y value is at 1. I multiply it by a fourth. That means these are going to be at a fourth. If I take my minimum and the y value multiply, it's at -1, and I multiply it by a fourth, that's at -1/4. And then if I take the zeros and the y value is 0 and multiply it by a fourth, well, it's 0. Notice this, this function of cosine function with a compression, it pushes your y values towards the x-axis, okay? Period for this, well, it's 2 pi. That's when I see one revolution, one period of my unit circle. All right, let's scroll down and talk about reflections. So a reflection is when and it's a negative out in front. That reflection is when your graph is reflected over the x-axis. So let me go ahead and draw that parent function for you. That way you can see it. Get my zeros in here. All right, so here's my parent function. All right, notice parent function here, amplitude is 1. Now, if I reflect every single one of these points over the x-axis, well, let's see. If I reflect our maximums at 1 over the x-axis, then I get -1. If I reflect the minimum, which is at -1 over the x-axis, it's at 1. And zeros, well, they're on the reflecting line, and so that's where our preimage equals our image. Here is your reflection of the cosine function, okay? So you're reflecting each point over the x-axis. All right, I think that about covers our vertical stretches, compressions. That's where you're multiplying the y values by whatever that amplitude is, and then your reflections is when you're reflecting it over the x-axis.